Welcome to Tutor-E's Chemistry Hub, where we make chemistry as simple as it can be. However, today we are discussing mathematics. That's our main focus, mathematics and chemistry. And we have the same mission for the both of them, make them as simple as possible. So let's get right into it. We are today discussing indices, one of the basics of mathematics. It's quite simple, so let's go into it and watch the whole of the series, because from indices, move on from simple to difficult questions, and then we'll move on even to exponential equations. Here we have indices questions that leads to quadratic equations. And then, if you don't know quadratic equations, fear not. We'll be using formula method for our examples. However, we will be discussing quadratic equations in subsequent videos. As I've said, we will be dealing with both chemistry and mathematics. All right, so let's see. The laws of indices. This is the basic of knowing anything about indices. Just be familiar with the laws. There are 5 or 6 main laws depending on how you look at it. Some can expand it to 7, but some are basically just mirror images of each other. So it depends on how you look at it, but the main laws are actually about 5 or 6. So let's see. The first is the law of multiplication, which says that when you are multiplying two index numbers which have the same base. Now the first thing is, what do you call a base? Whenever you have a number like this, the one at the top is called index, or some can say power, and the one written below is called the base. So you can see the base here is A, the base here is A. When you are multiplying, you simply pick one of them, and because you are multiplying, that means you add the powers. That's all there is to the first law. So let's have a generic example for now. Later we'll start moving on to other examples. So let us say we have 5 raised to power 10 times 5 raised to power 8. There are 2 ways to go about this. The first way is you can say 5 raised to power 10 means 5 times 5 times 5 into 10 places times 5 times 5 times 5 into 8 places. But you agree with me, that takes up a whole lot of time. So the simple thing is, the base here is 5, the base here is 5, and they are multiplying. You pick one. Because it's multiplication, you simply add the powers, and you get 5 raised to power 18. Number 2, the law of division. It says when you are dividing 2 indices, again, and the bases are the same. Now this can be written like this, or you can also be written like this: a raised to power m over a raised to power n. They both mean division. So when you are dividing, again, you check out the base. If they are the same, you pick one, and then because it's division, you subtract the powers. So an example using the same generic one we have over there: 5 raised to power 10 divided by 5 raised to power 8. Again, you can apply the same principles where you put 5 into 10 places, and then you put 5 into 8 places. By the time you cancel out, you have your answer, but that takes a whole lot of time. And the purpose of the law of indices is to save you that time. So you have the same base, you pick one, then because it's divide, you subtract. Sorry, that should be 10 minus 8. I'm already thinking forward to the answer. So you have 5 raised to power 2, which can go a step further and say that is actually 25. Now the first thing to note about this, as you can see, the condition is that the base must be the same. If this is 5 raised to power 10 and I have 2 raised to power 8, the base are not the same, so the law of indices will not apply in such cases. These 2 laws only applies when the bases are the same. And remember, what is the base? The base is the one you write below, and the power is the one you write at the top. Next, we have when you are multiplying two powers. In that case, what happens is you have a bracket, you have an indices inside a bracket, and then there's a power outside the bracket. So what goes on here is, as usual in regular mathematics, you know, whenever you have a bracket, you expand the bracket. And how do you expand the bracket? You use what is inside to multiply what is outside. In this case, it's a power that is outside. So what you simply do is you use the power inside to multiply the power outside. So you have a raised to the power m times n, which equals, if you are going further, m times n simply gives you mn. So again, an example, trying to work with 5, 10, and 8 here. You have 5 raised to the power 10 bracket raised to the power 8. So what do you do? Open your bracket, use the power inside to multiply the power outside. You have 5 raised to the power 10 times 8, which equals 5 raised to the power 80. Guess that number is quite large. Alright, so move on to number 4. Now this number 4 is going to help you in some certain questions. Say you have AB raised to the power m. What's going on here? You have two bases. Remember, this A and B can represent numbers practically, or in some questions they can also leave them as alphabets. So A and B together raised to the power m. What that means is that the raised to the power m affects the A, and the raised to the power m affects the B. Now this is what actually happens here. Let's break it down. However, your answer is going to be something like A raised to the power m times B raised to the power m. So the power affects the both of them. As I said, this is not really a different law per se. It is a variation of law number 3. How is the question you may ask. Here is how. You have A. Now the point here is that whenever you have a number without a power, it is actually raised to the power 1. So you have A raised to the power 1, then you have B raised to the power 1. They are both raised to the power of m. So now, remember what I said in law number 3, to open the bracket, the power outside needs to multiply all the powers inside. That means the power outside will multiply the power of A, the power outside will also multiply the power of B. That means you are going to be having A raised to the power 1 times m, and then B raised to the power 1 times m. So you have A raised to the power m, B times B raised to the power m. So that's exactly how you get what you got earlier. So you can see it's merely a variation of what you have in law number 3. However, why is this useful? In some questions, you may have something like this. Let's just use this for now. You have 6 raised to the power 4. What do you do? 6 is the same thing as 2 times 3. So you have 2 times 3 raised to the power 4. This can be expressed as 2 raised to the power 4, the power multiplies the both of them, times 3 raised to the power 4. There are going to be specific questions where you may need to have break a number into its factors so you can be able to actually use it to solve. As you are applying these laws to much more advanced questions, you'll be seeing these laws in place, and that's the reason why I'm bringing them out here. Now you can have something like xy raised to power, let's say 5, still trying to use 5 over here. So what happens? It becomes x raised to power 5 and then y raised to power 5, and so on and so forth. So you can use it as much as you want. Because the beauty of indices is being able to know how do you use the laws at a particular time. There are times where you need to make, well, let's just leave it as at now. Later, as you are seeing such questions, we'll be applying them basically. Alright, so for law number 5, we have the law of negative powers. So we have a raised to the power minus m. Whenever you have a negative power, or you call it a negative index, as I said, it can be called index of power. So some will just say negative indices. It means the power is negative. Whenever you have a negative power, you make it become 1 over. 1 over, and then the negative power disappears. Now take note, you use this when the power is negative. If you have minus a raised to power m, the power is not negative here, so you don't make it become 1 over a raised to power m. No. When the power is negative, you make it become 1 over to eliminate that negative power. So note that. An example, if you have 5 raised to power minus 2, that is the same thing as 1 over 5 raised to power 2. Again, law number 6. Well, before I move on to law number 6, I always like to make things easier. This again is a variation. Whenever you have a negative power, what do? Make it become 1 over. If it is a whole number. But what if it's a fraction? A over b raised to power minus m. What do we do in this case? Again, you can make it 1 over, but that is a waste of time. So practically what I advise people to do is just turn the fraction upside down. So it becomes b over a raised to power m. Once you turn the fraction upside down, it eliminates the negative power. Now again, for some explanation, if you had made it 1 over, that means you'd have been having 1 over a over b. This is something as saying 1 divided by a over b. Whenever you have divide, you can't solve anything, make it become times. So it becomes 1 times b over a. Make this over 1 so you can multiply fractions. 1 times b is b over 1 times a is a. So you see, you have exactly the same thing. But having to go through that process is going to take you a whole lot of time. So the easiest and simplest way is turn the fraction upside down. You can practically see, if you are having a raised to power minus m, that's written as a over 1. So because of the negative power, you turn it upside down, you have 1 over a, which is the same thing as this. But we don't need that, so I guess we can delete that off. So that's exactly the way it works. Now, let me just give one example in this case. So an example, let us say we have 5 over 3 raised to power minus 2. This we will be applying more than one law. So let us watch it carefully. Because the power is negative, what do? Simply turn the fraction upside down. So it becomes 3 over 5 and the negative power disappears. Now what happens? Mbao said earlier, whenever we have a power outside the brackets and there are two numbers inside the bracket, the power affects the both of them. That means we should be having 3 squared over 5 squared, which equals 9 over 25. So that's practically how you do that. And then the next one is when you have a fractional index. So you have a raised to power m over n. This is quite simple. All you just need to know, if you have a remember the fractional index, that's to say the power is a fraction. all you just need to know is the denominator equals the roots and the numerator equals or remains a power or index. So what that simply means is that in the fraction, n is our denominator. N becomes a root. So we simply have nth root. We still have the base. And then the numerator, which is m, remains the power. So it is just that straightforward. Again, a variation of this is when you have 1 over m. Let's just take the variation before we have an example. You have a raised power 1 over m. And people will tell you it just becomes m root of a. Well, what is the reason? Remember, fractional index, the power becomes a root. So you have m root of a raised to the power of, the numerator remains the power, which is 1. And you already know anything raised to power 1 is the same thing. So it is practically m roots of a. So you can see the both of them are variations of each other. And then we can have an example. Let's say we have 8 raised to power 2 over 3. What happens? 3 is the denominator, right? Becomes a root, which we call cube root of 8 raised to power 2 remains the power. What is cube root? Cube root is the number which will multiply itself 3 times to give us 8. And the way I like to do it is simple to get, but you can simply do this. 8 divided by prime numbers. 2 divided 8 is 2. 2 divided 2 is... Sorry, 2 divided 8 is 4. Sorry. 2 divided 4 is 2. 2 divided 2 is 1. Remember, what does it say? Number that divides itself 3 times. 2 divided 3 times. So that means your answer is simply 2. Raised to the power of the power outside, which is 2. 2 raised to power 2 means 2 times 2. And that gives us 4. And that there is our answer. Well, just to add some fun to it, let's have this. We have, let's say 1000 raised to power minus 1 over 3. Just trying to make it fun. What's the first thing we do? You observe the index is negative. Once you have a negative index, what do? You have to remove that negative. You introduce a 1 over. And then the negative is gone. What's the next thing we do? Because the index again is negative, that simply means this 3 becomes a root. So we have 1 over 3 remains a root, which is cube root of 1000. Because raised to power 1, at times you can just simply leave it out. But in this case, trying to follow the law to make it clear. So we leave it there. So we have 1 over. Next thing is, what is the cube root of 1000? If you are familiar with it, you know it is 10. However, just trying to show something, take 1000 divided by prime numbers. 2 divided 1000 is 500. 2 divided 500 is 250. 2 divided 250 is 125. 2 can no longer go. What is the next prime number that can divide 125? It is 5. 5 divided 12 or 125 is 25. 5 divided 25 is 5. 5 divided 5 is 1. So what do we have? Cube root, a number that does it 3 times. So 2 has done it 3 times, you pick 1, 2. 5 has done it 3 times, you pick 1, 5. So the cube root of 1000 is therefore 2 times 5, which gives us 10. So we have 1 over 10. Again, raised to power 1 means nothing, so we'll simply leave it at that. And our answer is 1 over 10. I like to show this without using calculator, because some of these questions, it is faster to even use your head than to use calculators. All right, and the final one, the final law, law number 7, it says anything raised to power 0 equals 1. And those are your laws of indices. Now, most times, I don't think anybody will give you a question that says 10 raised to power 0. Nobody will do that. But most times, it's a question you solve. After solving, you get to have raised to power 0. An example, let's say you are given 2 raised to power 3 times 2 raised to power 2 divided by 2 raised to power 5. Something like this. Just trying to put on more laws for us to see and use the laws, because most times again you won't just get a question that gives where you apply only one law. It will be a combination of laws. So now it's quite simple. You are dealing with multiplication and division. That means you just check if the bases are the same. 2, 2, 2. So the bases are the same. You pick one. The power here is 3. Because you are multiplying in this case, it becomes plus. The power here is 2. Because you are dividing in this case, it becomes minus. And the power here is 5. So what do you have? 2 raised to power 3 plus 2 is 5. 5 minus 5 is 0. Anything raised to power 0 is 1. So most times you will not be given a question where they tell you something raised to power 0. You calculate and get to that point. However, some years ago, I gave some students this question, and many of them stressed themselves before they even got the answer. When the answer, you should have gotten it in less than 10 seconds, I guess. So you have a raised to power 3 divided by a raised to power 2 plus a all raised to power 0. Many of them solved and solved and solved and solved, and then they finally got 1, which is the correct answer. Well, I still mark the answer for them because they got the answer anyways, but the point is, anything raised to power 0 is 1. Everything here has been raised to power 0. So your answer is 1. You don't need to waste time with it. But just to show something, anyways, before we leave, observe this. Your laws of indices, we have spoken about them since. No one ever applies when there is plus. So don't ever think of the law of indices when you are having plus. So what happens in this case? Remember, you have mixed operations here. You have divide and you have plus and you have brackets. You simply have to remember board mass. In board mass, the bracket, so we are solving what is inside the bracket first. And inside the bracket, we have division and addition. Division comes first. That means you are going to be having a raised to power 3 minus 2. The same base, pick one. Plus, nothing concerns a. And we have not solved the raised to power 0 yet. So then we have a raised to power 3 minus 2 is 1. We don't need to write the 1 because it's power 1. Plus a raised to power 0. Now this is plus, not times. So you have no business with the law of indices. You solve this like a regular algebra. A plus a gives us 2a raised to power 0. Anything raised to power 0 is 1. So this is still our answer. However, I just did this to show us that the law of indices has no business when you have addition or subtraction. Alright, so watch out for more questions, watch out for more examples, and remember, the key is always practice. That makes you better. Like, share, and subscribe.